Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So in a real interview, the first step is always try to understand the problem. If there is anything you feel unclear, please bring up the question. And also, at the same time, think about some edge cases at the very beginning. So let's take a look at the question. The lowest common ancestor of a binary tree 4. So given the root of a binary tree and an array of tree node objects nodes, so return the lowest common ancestor of all the nodes in the nodes. So all the nodes will exist in the tree, and all values of the tree's nodes are unique. So extending the definition of LCA on Wikipedia, the lowest common ancestor of n nodes P1 to Pn is a binary tree T in the lowest node that has every Pi as a descendant. Alright. So let's take a look at the example. Let's see this one. We have the tree like this. We have two nodes 4 and 7. The LCA is 2, of course. For example 2, we have just one node, and the LCA is 1 as well. Is just 1. Okay, so for this tree there are 4 nodes, 7, 6, 4, and 2. Okay, so the LCA is 5. Alright, so let's say for this one, like all nodes, then the root is going to be the LCA. So I think we are pretty much in good shape understanding question. Let's see some constraints. So it said that the numbers of the nodes are in the range of 1 to 10k. Each node is between -1 billion to 1 billion. All the node values are unique, and all the nodes I will exist in the tree. All the nodes I are distinct. Okay, so all the nodes I are distinct, and all the nodes will exist in the tree. Okay, so I think having said that, I don't see an obvious edge case here, because it makes sure that the tree is not empty, and also everything exists in the tree. So having said that, I think we are in good shape for the first step. Let's go to the next step, which is about finding solution part. So in this part, you're about to find the idea how to solve this problem, discuss with the interviewer about the solution, and also do some necessary runtime space analysis. So let's see how to solve this problem. So I would say it could be we use Dfs to solve this problem. So the Dfs function is something like this. So remember, we also have a similar question, which is LCA. I think it's 2 or whatever. So it's another lowest common ancestor binary tree question, but the difference is that we just try to find the LCA for two nodes, but here it's like a list of the nodes. So it's actually similar here. So we just define the recursive function. Let's say it is Dfs function, and if the left subtree, if there is some nodes in the left subtree, and there's some other nodes in the right subtree, then we can say that the root is the LCA for all of the nodes. So if all the nodes exist in the left subtree, we should say that the left subtree is LCA. And similarly, if every node is in the right subtree, then we can say that the root of the right subtree is the LCA. So using this idea, we could use Dfs or recursion to solve this problem. And the runtime is going to be all of n, and is the number of the nodes within the tree. So having said that, let's give it a shot by doing some coding work. So for coding, we care about the correctness of the code, the readability of the code, and also the speed, so don't be too slow. So let's see, because the nodes are given in an array, so we could actually turn it into a set for easier comparison. So let's say we define another helper function to turn it into a set. So let's say this is going to return the set of the tree node. Let's say this is list AR to set. So this is tree node nodes and set tree node set is equal to new hash set tree node from the nodes. You just iterate through every node in the array and add it into the set, and finally return the set. So I'll say let's say node set set of the tree node is now set as equal to ARR2 set nodes. And so okay, so I think there's some constraint. I definitely remember some constraints. So it says the tree is not empty, and everything is unique, but it didn't say like if the nodes array could be empty or not. So if it is empty, then what should we return? Should we return none, or should we just throw an exception, whatever? But here, let's assume there is assumption that the nodes array is never going to be empty. So after we turn it into a set, we will call let's say find LCA to find the return find LCA. It's on top of root and the node set. So let me define a helper function here. So let's say find this is going to return the tree node. Find LCA. So this is tree node root tree node no, set actually. So this is node set. So if the root is equal to a none, then we just simply return a non-pointer. So if the root is within any of the nodes in the set, then we are just going to return the root itself. So if a node set dot contains the root, then we are going to return the root. So this is the exit of the recursion, and after the exit definition, it's a general logic. So we will say tree node left is equal to find LCA root the dot left node set, and also similarly we traverse the right side dot right the node. So if left is not equal to none and right is not equal to none, then we are just going to return the root, because the nodes exist in both left and right subtree. Otherwise, it means that otherwise we just see which one is not none, and then we finally return them. So otherwise we would turn left is equal to none. If yes, then we are going to return right. Otherwise we return left. So this would be pretty much about the coding part. Let's see testing. So how to test this piece of code? So usually you do some sanity check by running through some simple test cases, and do some sanity check at the time, fix the bugs in the logic, and explain how this piece of code is gonna work. So let's see this one. We have let's use example 1, 4 and 7 stuff. So at the very beginning we are at 3, and then we go to the left side, and then the left side this and then in this part we call left and right correspondingly. For this part, the left is going to return none. For right, we go to the two parts, 7 and 4. So for this one we call left and right. So both side left and right are not going to return none because it contains the corresponding nodes we are trying to find. So we are going to return this node when we call find LCA find right, when we call it here. So we turn this node, and then we are going to return this node as well. So for the right part we have nothing, so we are going to use the return value from the left call to serve as a return value for the root. So we are going to finally return 2 at this moment. So it looks fine. Let's take a run to see how it works. So it's compile error. Let's try to fix this typo. Alright, so it works. Let's give it a submission. Okay, so everything works well. So that's it for this coding question and about the solution of this puzzle. If you have any question about the solution or about the puzzle itself, feel free to leave some comments below. If you find this video a bit helpful, please help subscribe to this channel. I'll see you next time. Thanks for watching.